Show that the equation, question 4 says, show that the equation sin x minus cos x is 6 cos x over tan x can be expressed in that form. Well, actually, you know, rather than worry too much about where we're going with this to start with, let's start by just thinking, can we do some of the some of the obvious things here. We've got a tan x on the bottom of our fraction. So the obvious first thing that we might want to do is to multiply throughout by tan x. That would seem reasonable, wouldn't it? So that gives us tan x sin x minus tan x cos x is 6 cos x. Which, well, we can deal with this in a few different ways. This gives us, we're wanting to end up with tan x's in here, aren't we? And the problem is we've now got sines and coses going on as well. So let's divide everything by cos x, because we know that sin x divided by cos x goes to tan, doesn't it? So the next move is we're going to divide everything by cos x, which gives us tan x times sin x over cos x minus tan x, because the cos x would cancel out, equals 6. And really, the marks here were for noticing that, or for clearly using, that sin x over cos x is tan x. So that's tan x minus tan x is 6, which is tan squared x minus tan x minus 6 equals 0. And that would be the neat way through it. There were a few people who mentioned the fact that tan x equals sin x over cos x. But just mentioning it isn't enough. It's got to be used in context. You've actually got to use it to get the credit for it. And that always goes for these trig identities. It's never enough just to mention them. They have to be used in context. So, you know, if you get a question that talks about the sine squared plus cos squared equals 1, and the different variations on that you can use, you have to use them. You can't just quote them to get them out. So part 2. Hence solve the equation. Well, actually, you know, we can ignore that. We can go straight into saying that is the same as this equation. We're looking between 0 and 360. So we've got tan squared x minus tan x minus 6 is 0. It's up to you how you want to do this. You can go straight to factorising it, or you can do a little bit where you imagine it written as being something like t squared minus t minus 6 is 0. If that is easier for you to visualise what's going on. It's a quadratic to factorise. Two things that multiply to give negative 6 and add to give minus 1 must be minus 3 and plus 2. And make sure that we get our factorising correct, which gives us that t is 3 and t is minus 2. Did you have the signs to remember?
Yeah.
So tan x is 3 and tan x is negative 2. And for some reason there are a few people who did this bit really well now. So inverse of tan, can I remember what they were? Inverse of tan is 71.6, is that right? The inverse tan of 3 was 71.6. If you're doing the class diagram method, you then draw your little diagram, draw it in there, that's 71.6 there, so that's 71.6 there. So it's 180 plus 71.6, which is 251.6. So that's our other value. And then I had a couple of people who said tan x being 3 is fine, but tan x can't be minus 2. That's outrageous. And so that said no values for that. But why not? Tan x can be minus 2. So we do inverse tan of minus 2, and we get a slightly awkward value, don't we? We get minus 63.4. And again, you've got to be careful. We know what we're doing with this, so don't we? We've got to be careful we don't look at that and think, that's not in the range 0 to 360, let's ignore it. Because again, we know that if we get that negative value, that's there, isn't it? And it would also be there. That's the other place that tan is negative, so 63.4. So actually, we're interested in that value there, and that value that takes us all the way around to there. So there are two values to get from this. They are 180 minus 63.4, which is 116.6. And we've got 360 minus 63.4, which would be 296.6 as well. Okay, and so that's enough. It's neat though, isn't it, to write your answers to three significant figures, because that's what we want in ascending order. So I would have written 71.6 degrees, 117 degrees, 252 and 297, and there's my answer, all neatly written to 360. All right, everybody happy? Thanks, Jane. Good job.